All right, I'm going to create a new project, a new solution, section 12.2, because we have a lot of input that's going on there. And so I'm just going to copy and paste some of that top information, the includes, and the namespace. I'm going to copy that into here, which means that I'm going to go open the other one, copy the information, and bring it in here. But if you don't know where the first one is, or if you don't know where your solutions is, the best way is to create a new one. So if I say File New, Project, I tell it that I want to be a console app, I can see where it's actually going to put it. And that way I know where I can find my first one. So once I say that I want to open it, I navigate to my desktop. Now that I know where it is, I'm just going to click on the solution file to open it. And then I'm going to copy some of the relevant information from the top. So I'll update my description on line 3, and then I'm going to create a couple of variables. Let's create an integer, a numerator, and a denominator, and a quotient. And let's see, and I'm actually going to create a string error message. I'll say the input stream is in error, and then we are going to try a try catch. So in the try catch, we're going to start with our try, and we need our opening curly brace. And I can either put a comment on here and then start my catch below it. The catch needs the parentheses with its opening and closing. Or, as we have seen before, we can put the catch right on the same line as the closing curly brace. This will help me to make sure that the catch immediately follows the try. So inside of here, we'll come back to decide what we want to catch in just a minute. So inside of the try, what I'm going to do is prompt for the numerator. So we'll prompt for the numerator, and then we'll read it in. I'm already regretting spelling that all the way out. So one of the things that we know that can happen if they key in something that is non-numeric is it could cause my input stream to go in failure. So I can put an if statement in here that says if my input stream is in failure, I'm actually going to throw the error string. Now, I happen to know that my error string is a string. So I'm going to come down here and see if I can catch a string. So I'm going to catch a very specific data type. I'm going to catch a string. Let me come back over here. And then I am going to give the string a variable name. This is like a parameter in a method or a function. I'm going to give it a name error. And then if I am catching that string that is being thrown on line 23, then we know that our input string, is in error. And so I know how to clear that error in my input stream. All right, so there's 3 things that I want to do inside of this catch. I want to clear the error, clear the input stream, and then obviously tell the user that something went wrong. The nice thing is that I threw this string error message, and so that's what I'm going to display to them. All right, so once on line 27 I have cleared the error, and on line 28 I have ignored everything else in the input stream. Remember, in order to use int max, we have to pound include climits from line 7. I can see that on line 7. Then we're going to tell the user that something went wrong. So here, I am going to tell them that there was an error, and then I'm going to mirror back my error that I threw. So the parameter, when I caught it, I called the string message ERR, and so I'm just going to mirror back the ERR, and then we're just going to test it. So for the first test, I'm going to do something successful, so I'll just put a good number in here, and it should be good. For the second test, then I'm going to see if we can blow it up or put something invalid in there. So now I would expect the input stream to be in error. I'm going to throw that message to my catch. I'm going to catch it, and then it's going to say error, and it's going to mirror back the string message that I threw. All right, and since we were doing fractions, we are going to prompt for the denominator. So now I might say, enter the denominator. And then we will read that in. I believe I called that denominator. Oh, the CN goes the other direction. There we go. And then, of course, it seems like they could also put in something invalid in my denominator. So I'm going to try it again. If not CN, then we are going to throw the error string. And since I'm already catching a string, I shouldn't have to do anything else. I already have a catch statement that will catch a string. So my numerator, I know my numerator is working. The denominator, I should be able to, with my input stream goes into failure, I should be able to throw a string. I have a catch that will actually catch a string. So we'll put that in there. But remember we said we could throw specific data types. So what happens, what would be another thing wrong that could be wrong with the denominator? Especially if I'm about to do some fractional work. What would something that would be wrong with the denominator? Absolutely. That statement would say if the denominator is less than or equal to 0, or actually not less than, if it's equal to 0, because we cannot have a 0 denominator, correct? So if the denominator is equal to 0, that is going to be a serious problem. So what I probably want to do is, this time I want to throw something so I could tell them, yeah, you can't have division by 0. So what I'm actually going to do is I'm going to throw the denominator, because the denominator would be a 0, right? So let's throw the denominator. What data type is the denominator? So I have a catch of a string, and it seems like I should probably have a catch for an integer. So let's add another catch. I can chain or cascade catches together. This time I'm going to create an int, or I'm going to catch an error. And now we're going to tell him that the denominator cannot be 0. So inside of here, I will see out something like error division by 0 to let them know that they cannot do division by 0. And then we'll test. All right, so I know both my numerator and my denominator are catching for invalid input. And so I'm going to test my denominator for an invalid input into a denominator, which would be 0. And if I catch it, there I can see that I have my error division by 0. And so I'm going to clean this up a little bit. I'm going to drag the catch up closer. I'll put the second catch, or the chain catch, below that. And then I'm going to put the whole entire thing inside of a loop. Let's put it inside of a do-while loop. Actually, before we put it inside the loop, I'm going to go inside of my try. Here's the try. I'm going to go right above the very first catch inside the try. And if it worked, and if nothing went wrong, I guess the whole point of this was to calculate, right? So we're going to say the quotient, which is a variable that we created, is equal to the numerator divided by the denominator. And then we will output something like quotient. And that would be the quotient. And then I'll even put a couple of end lines in there. So inside of my try, once I am past all the different things that can go wrong, if it worked at the very bottom of my try, I'm going to say that something went right. So This is what it looks like. 15 divided by 3 should give me a quotient of 5. So let's put the whole entire thing inside of a loop. So that would beg the question what I'm going to loop on. I really would like to do a do while. So if I come up here, this is where I want to start my loop. So we'll have the opening curly braces for the do, and then I'm going to come all the way down here at the bottom of it, and this is where we want to close the while. So I can have the while loop down at the very bottom. Of course, all of this should probably be tabbed in. So I'm going to select it, and I'm just going to tab it in so that I can see I'm inside of a loop. That would beg the question, what do I want to loop on? How do I decide what to loop on? The idea is if they got it wrong and it threw an error, either a string or an int error, the program just ended, right? And I would really like to be able to do it again. No, that wasn't right. Do it again. I'm telling them something went wrong. I would really like to be able to say, try it again. But I have to have something to loop on. So what we're actually going to do to loop on is I'm going to create a Boolean variable. And I'm going to call it valid. So we'll just create, oh, no, it's C++, it's the word bool. I'm going to create a Boolean variable that is a valid flag, either positive or negative. So when I first drop into my try, I am going to set the valid flag. I'm going to assume that everything worked well, so I'm going to set my valid flag equal to true. And then, if something goes wrong, and I want to do it again, right before I leave my catch, I am going to trip the flag. So I'm going to go to my first catch, where I was catching the string. I'm going to go down to the very bottom of the catch. There's the closing brace for the catch, and I am going to set valid equal to false, because something went wrong. I'm going to do the same thing with my second. I'm going to come down here, and we are going to, if this goes wrong, I'm going to trip the flag, and I'm going to set valid, oops, spell it right, valid equals to false, and there is the end of my catch. And then I'm going to loop on the value of that valid flag. So, because my valid flag is either true or false, I could say while valid is equal to false, but since valid is a Boolean variable, I am just going to set while not valid. Now let's see, we have my cout that is not happy. All right, let's see if we can get this to repeat. So we'll have a numerator. If I put in something invalid, it asks me to do it again. If I put in something valid and I blow up the denominator, I'm going to have to put in a numerator again. If I put in 0 for my denominator, it is telling me division by 0. I need to force a new line after that error statement. Enter a numerator. I can do it again. And then once I put in valid values, my program runs. I'm forcing valid using the try catch and the input stream and failure. One thing I did want to mention is if I put in a valid numerator and then an invalid denominator, I have an entire do while loop that is forcing them to go back to the numerator. Well, they already put in a valid numerator, and so it seems like it is failing on the denominator, correct? So for user interface, user experience, it seems like perhaps you might want to put maybe the numerator read inside of a loop and the denominator read inside of the loop, so you can, instead of forcing them to key in a valid numerator again when they keep failing on the denominator, you could specify that they're failing on the numerator, make them do it right, and then failing on the denominator, making them do it right. It's just with a mind towards the user experience. So as we continue on the course, we're going to find out that there are other exceptions or errors to be thrown, but for now, this is a great way for us to be able to force valid input. So your video lab for section 12 is just to practice out exception handling. And so I'm going to have you write a program that's just prompting for a couple of numeric input. I want you to force valid input, not only a numeric input, but I also want you to force a range for the length and the width, display a friendly greeting and a graceful close, and you're going to mirror back all the relevant information to the user, and I would like you to include some test cases.